Okay, let's get right into our second lecture, which is going to follow your reading a little more. Um, so we'll go kind of fast through this stuff because you're being asked to read chapter 4 in Powell and Baker, and I'm going to use some examples from that. So if I can get, yeah. So just to overview, the real concept here, the thing we're trying to drive home is design, then build. If you look at Powell and Baker, they give 4 in that chapter you're asked to read. They go through 4 different versions of ways you can think about design or sort of concept modeling, writing things down before you start thinking about this is the data I have, this is the data that I need, and I'm going to put these things in the spreadsheet and we'll deal with it later. Of course, their philosophy being, if you can't write it all down and start to fill it in what you have and what you don't have, then you're not following sort of the right process. The common theme is this idea of planning your model. Think about the interactions and the assumptions and specify those. Make this blueprint. That is not just a blueprint for the model, but it's a blueprint for the data that you'll collect and validate, right? Try to check on and understand how it arrived to you, how you'll implement formulas, equations that are going to drive the analysis, how you're going to conduct revision and review, how you'll think about communicating results. A good diagram is a great way to present results. It's a good guide or a framework for how you might show somebody and explain to them what's going on. And again, analysis. So anytime we're revising and reviewing, we're going to do what we would call this analysis step again. And then of course it gives you these blocks where you feel like you haven't modeled well, or where the assumptions may be poor, that would show limitations or future work you might consider. Diagrammatic models have this sort of common feature that they tend to look the same over and over. And so if you were to think about a diagram of the national economy, you would have something about maybe end users or households that buy things and do the consumption in an economy at the top, and they might consume it as sort of private expenditures or public goods through the government, however you want to think about it. And they might consume some of it as future consumption and savings. At the other, that's sort of the top line. The other line, you'd have the makers, or the producers, or the converters, whatever you want to call them, the firms. And what do? Well, they sell goods. But there's another set of transactions. The households also own the resources of production, right? So, because ultimately, the people here, the end consumers, the buyers, own the capital, they own the firms, right? They have stakes in those things. And so, you end up with this sort of two-way thing. We're going to make this sort of the technology of the world, the firm, and it's going to buy those resources from the household, do the conversion, sell back as final consumption goods. And then, of course, taxes, right? So you have a sort of a policy. And so every national economy sort of fits this model as we would write it over here in this short outline. When you think about trying to fill it in with data and trying to figure out how the taxes move through the economy, and I'm not asking you to know anything about what's going on up here, other than household top, firms bottom, and then policy sitting in between, putting in these wedges or putting these extra spending amounts on all the transactions. That's the common part. This picture here is specific to GTAP, specific to a very small piece of GTAP, the Global Trade Analysis Project model of the global economy. So this is for one region of that. And so, that's sort of a feature. The diagram, if you strip out the stuff that's specific, would look the same for everyone. This sort of the idea that regional spending is either for private or public consumption or future consumption, and that firms take resources and convert them into final goods. that is common. The GTAP part is the same. And so that diagrammatic picture of the national economy is something that we use for decision models as well. We tend to call them influence diagrams in this context, or influence sketches, influence maps, I believe is the other thing that gets used. And really it's about starting from something in a decision model that is the objective, the sort of scoreboard or the measure of how well we're doing, and finding your way, tracking your way backward to a decision. And so you can see over here on the left, I've actually drew one out a few years ago for that speed model, and it's not a very good attempt, but it does, I'm not talking you through it either, but it does sort of lay out the different decisions, kind of brackets those, and tries to make clear what the sort of hard limits are, and the idea that you have to come up with a speed recommendation for the driving. This one, like the national economy model, would look the same for every situation. You get some measure of profits, and it can be split into total revenue and total cost. And the work in the influence diagram is start to break those apart until you can start to find things that are clearly going to have to be made as assumptions or sort of fixed signals versus the things that we have the ability to control, that the decision maker is going to be allowed to make changes to. So these are visual tools. They can be maps for building quantitative tools. A good rule, every one of these textbooks, I've reviewed them all, has some different rules they say to follow. I consider it to be a sort of a free-form exercise as long as you know what you're doing. As long as you're being deliberate and not skipping steps, then you're probably doing well. A good test for yourself, a good question to ask yourself is, how well could you use this to, one, develop your quantitative model, capturing those same relationships, and then two, compare or defend your modeling choice against some alternative, right? If somebody started asking you questions, could you show them your diagram and make the case for what's been done? The structure, the sort of loose 5 steps here, begin with the outcome measure. That's the signal of success or failure for the decision maker. Decompose it into factors that directly define that final outcome. Continue that decomposition. You're looking for components that can't be broken down further. One rule that is fairly common, a factor should only appear once. And that means if you're tracking down a branch and you end up with the same sort of factor that's already been described somewhere else, then you need to link those up. That's because there are 2 paths that decision or that control or that influence factor, that it follows 2 different paths, and we're going to see how that plays out and why that's important. And then eventually you have to get down to the decision or control factors, and typically those are made with some distinction. They're drawn separately or recorded separately to make clear their importance. So the basic rules we have start from the end, where profit is our target. What directly influences it? Well, we know the equation is revenue minus cost, so we could directly insert that. And then if we were to continue to try to break things down to do extensions, we might think about fixed versus variable cost being the measure that enters as total costs. So total cost is some subordinate outcome to profits, and we will want to talk about how to do that. So I don't want to keep drawing when asking you to read a specific case or a specific incarnation of this influence diagramming or influence charting. And so you can follow Powell and Baker, and that's what I'll take the rest of the graphs from here. They all advocate for different styles. Powell and Baker, I think, is a good one to read because they have a very structured approach. They want different shapes for everything, and I'm not saying you should do that, but you should be aware of the differences in the shapes, the difference of the designations in your own diagramming. So they're going with the objective variable should be an octagon. You break it apart into revenue and cost. And then they're going to think about further breakdowns using endogenous variables, something we defined before, being ovals, and endogenous being ovals and exogenous being triangles. Okay, so you see ovals here because something else needs to be uncovered before you get to total revenue, right? That is going to be a calculation that we make. Total cost is the one they actually start by breaking down into variable cost, an oval, meaning that it has to be calculated, and fixed cost, which is exogenous, and that exogenous variable gets a triangle. So this fixed cost is exogenous. The only way the fixed cost component will change is if we decide to change it by assumption. It's a by assumption variable. So if somebody tells us this is the level of fixed cost, they need to tell us when it changes. Or we need to make changes to it and see how sensitive the profit measure is to the changes in fixed cost. And if you know anything about fixed cost, you know why why we would consider it exogenous in this sort of marginal case, and why it probably has little play other than to be accurate about the returns. If we were going to decompose the variable cost, we might think about how it's influenced by its unit cost, which is a parameter, and the quantity we're selling. Right? So the key distinction of variable cost versus fixed cost is that variable costs change with the level of output, or the level of production. And so we have a unit cost which matches up to every unit, and that's fixed. That's a fixed parameter. But that variable cost is going to change because we're going to multiply the unit cost times the quantity sold. We know that this quantity sold also affects total revenue, though, right? Because total revenue is going to be price times the quantity sold. So why isn't that linked? Well, we're not going to put that relationship in until we're ready for it. So on this sheet, or this page, we are now thinking about total revenue. How's it influenced? Well, it's going to be influenced by this square, this box, the price, and the quantity sold. We get a new arrow going to total revenue. This box means it's a control variable or choice variable. It's not endogenous. It's under the decision maker's control. It's not a parameter. It's distinct from everything else, right? So it's something you're going to choose, just like our quantities of crops to plant in our linear programming crop models. So let me truncate this because there's one more thing that they have for us here. They are saying that not only does price directly influence revenue, it directly influences the quantity sold, and that's the demand relationship. Okay, so this quantity sold was endogenous, so we need to be able to break it apart further, and it turns out price is the thing that matters, and there's a parameter affecting that as well. It's called the elasticity. The elasticity here in the triangle is the sort of classic version of a parameter. It's a relational coefficient that tells us how one thing responds to something else, and it is a fixed value. And so, in that sense, it deserves its triangle. And there's an alternative to that. That's the demand, slope, and intercept. So you don't have to use elasticity. The elasticity is a percentage change measure. Demand, slope, and intercept are direct level measures. And so how might you do that if we had that sort of if we had this sort of map or influence diagram or influence chart? We might turn it over and build a spreadsheet model. It looks like this, and in fact you will build this spreadsheet model in your lab. So this is we have this sort of truncated module this time, so you'll use this for your lab. And we'll also talk about it some in lectures here. This spreadsheet has been split into the endogenous variables down here, the things that adjust are calculated as part of the model, and the exogenous factors up here. And so we have the pie price of $8 being a choice variable that's distinguished from the parameters, the exogenous things that matter for the cost side, the exogenous things that matter for the revenue side. And you see here I have the pi demand intercept and pi demand slope. Okay, so those being separate from an elasticity. It's essentially two things, right? So when the price is 0, how much do you sell? 48,000. And every time the price changes by 1 unit, by $1, how much is the amount you sell separate? So this quantity is going to depend on this price and these pi intercept and slope of the demand function. Yeah, and so that spreadsheet could have been built directly through an influence diagram, and so the other textbook that I took this example from works backwards from profit through revenue to pies demanded to pie price. So you can see they've got a bracket, or a bold line around this one to indicate it's a choice variable. And of course, what's interesting here is that the pies demanded, this quantity, tracks in two ways. It goes to the revenue, and it goes to the cost items, right? So the amount of ingredients required, right? So since quantity is going to have an effect on variable cost, it's tracking to both the revenue and the total cost side. The pie price directly influences something, the revenue, and then you could track away from the pie price and find out what it indirectly influences. Well, since it directly influences both revenue, because it appears in the revenue definition, and the demanded, the quantity part, then pie price has two effects in the revenue component, right? So a price increase will cause revenue to go up because we're charging more per pie, but it'll also have a revenue falls component, because the pies demanded will fall when we increase the price. We've already seen that's a downward sloping demand. And so that's really the interesting part of this. At the same time, when you're driving pies down, when you're driving the price up, you're driving the pies down, and you're driving down ingredients cost and processing costs. So you're driving down the cost, and so you have to ask, how do these indirect effects play off against this direct effect? Okay, where you're lowering revenue but lowering cost at the same time, and you're increasing revenue here. So what's it going to be? And that's why we need a model, because it's a very difficult thing for us to process, and we're going to build that spreadsheet. Yeah, and so in that lab, what are we going to be looking for? Well, we're going to test out the effect of variable cost terms, the effect of fixed cost terms, the effect of the demand parameters directly, and then we're also going to think about what is the effect of that price. And we're going to consider 1 versus 3, those sort of easier to understand components, versus 4, where we have both direct, right? The pie price having this direct effect on revenue, and then these which goes directly to profit, and this indirect effect which causes revenue to pull back down. Okay, so with that, I think we'll close out this lecture 2 in anticipation of our lab and working with that model.